So we were done with the overlapping. One was sigma overlapping and second was pi overlapping. So now let's talk about the types of overlapping. Types of overlapping. As you guys all know that unpair will be overlapped because they will be making the covalent bond. So unpair will be making, or you can say unpaired electron will be overlapped. Overlapped basically means the mixing. Okay, there are two type of overlapping. Number one is the sigma overlapping and second one is the pi overlapping. Sigma overlapping is having three types. Number one is S to S overlapping, second one is S to P overlapping, third one is the pi overlapping, which is the P overlapping. Okay, let's talk about the S overlapping. Let's take the example of S2. So this is hydrogen, unpaired electron will share. They will be making one single covalent bond. So here you can say that this is the nucleus of this hydrogen. This is the nucleus, not this is the atom of this hydrogen. This is the atom of this hydrogen. Okay, so if they will be, how they are overlapping, let's see. If they will be joining and they will be making a bond like this and they will be like sharing electron here. So this is, you can say that the SS overlapping means the sigma overlapping. This is the sigma bond between them. Now let's talk about the SP overlapping. Let me give you the example of SP overlapping, that is HCl. Let's take the example for example. So HCl, H is having the one electron unpaired and chlorine is having one electron unpaired. Okay. So in the last share of chlorine there are, you can say that one in last shell they are having the one unpaired electron, so they will be sharing. This will be the you can say that this is of course this is S px py pz. In orbital we are having S, then p have orbitals having 3 orbitals, so px py pz, you can put px here, py pz as you wish. So they will be overlapping, and how they will be overlapping, let's see. The hydrogen atom plus, because this is unpaired, so it will be making a pair, so that will be like that. You can say as negative and positive. Okay, so they will be making overlapping of, you can like this is a sign that in sigma there will be like a positive will be overlap first. So this is positive overlap and this one will be coming here. So they will be making like this and this will be like overlap. So this will be the large overlap sign of this, and negative sign of will be like small, because they both are joined. So in the increasing, the size increased and this one is getting a small. So this is called the SP overlapping. Okay, so now let's talk about the PP overlapping. PP overlapping, let's take the example of F2. Okay, okay, so F2, F here, and it is having F. So this is having the one electron, and this is also having one unpaired electron, and these are the lone pairs. So they'll be not making the bond, they'll be making the bond. So they share the electron and how they have shared the electron, let's see that. Okay, so in here you can see that we have taken negative here, because in the dumbbell shape there are like you can say that a positive negative both sign. Okay, one electron in negative and one electron in positive. So here you can see that there will be like this is you can say that this is S py pz, and here is px, and this is also px py pz, and s you can take here. So px and px will be making the bond like this. we are done with the orbital shape as well. P is having the 3 orbitals, which is px, py, pz, and px is having 2 electron, py is having 2 electron, pz is having 2 electron and 1 electron negative side, and that 1 electron in positive sign. So that's why 1 electron is having this sign px, and py will be having negative positive. So the resultant will be when of course you know that positive will attract. So positive and positive got attract, and negative here. So the overlapping will be positive will be joined together. They'll be making a large size increasing bond, and they'll be positive, and the negative will be getting small here. So the positive will be having large size because they are overlapping, and sigma positive will be saying, we will be saying that the positive. So the electron has shared one in anti-clockwise and second one is clockwise. So this is the electron cloud. This is electron cloud, you can say, because they are having high energy. Okay, so the first of all, the weaker bond is sigma bond. Oh, you can say that SS is more weaker because they are not having a large amount of size, and SP is little bit stronger because they are having a plus positive. They are having a little bit like you can say stronger like bond because they are having a greater energy than this, and this is having a large energy. They cannot break the bond easily because of the large size of the overlapping. This is having a small size, this is having a, that one is SP overlapping, this is PP, this is SP, and this is SS. So SP will be having the more, like you can say, a strong bond, and then SS because it is less overlapping, and this is more like because of the size, and this one is more stronger because of the size. They are having larger size than SS, and they are having more larger size than you can say that SP. So that's why they are having a larger size, and they cannot break the bond easily at all. So the sigma types are there. Now let's talk about the pi overlapping. We are done with the sigma types, and they are the overlapping, pi overlapping. Okay, so let's take the example of, for example, we are having a py plus py. Okay, we are like getting the electron of py and py. Okay, so this is a shape of the dumbbell. One is positive, one is negative, one is positive, one is negative. Okay, when they will be overlapping, so the overlapping will be here. You can see that sigma bond will be there. In that bond, sigma bond will be make this. Then after pi we are done with that video, and you can check it out last video. I'm already done with that all sigma and pi bond in detail. So the sigma bond will be making bond first because they are having the less distance, so they will be making bond, and then the pi bond. So sigma bond will be making the bond, like you can say that the positive bond, right? So this is sigma bond, and these positive will be like that. Okay, positive, and this negative will be like that. So this sigma bond is having the bond positive. I'm done with I said you that the second sigma bond always positive will be like making the overlap, and in pi there will be the positive negative both overlap. So the here is the sigma positive, and you can say that here is a positive, it is positive, negative, and sigma bond is already there, so they are having positive sign. So here sigma bond will be there, and this is like you can say positive, this is one positive, and this is one negative, because they are making the bond, and there will be size increase, and this will be size increase. So this is half electron, and this is half electron. One is anti-clockwise, this is clockwise, positive, negative. So they will be making a bond. You can see this one and this one as a pi bond, and this one as a sigma bond. This is half, one electron make Of course, two electron will be making a bond, if they are, you can say that unpaired. So this one is this one and this one will be making a bond. The one electron, two electron will be making a bond. Never single electron will be never making a bond. So this and this will be, this is half electron, this is half electron. They will be joining and they will be making a one. They will be like making electron cloud. So they will be like the positive, and sigma is already here. So this will sigma bond and pi bond as well. So this was the pi overlapping. You can take the example of pz as well. You can consider as well that there are more examples, there are too much examples. So today we are done with the types of overlapping.